So you're looking to cut through all the noise.
Hmm.
Yeah. And really get a handle on this tech trend that feels like it's about to reshape, well, pretty much everything. Something that goes beyond just, churning out text or cool images, but actually does stuff.
Yeah, that's the key word, doing.
Then you are definitely in the right place.
Yeah.
Welcome to our deep dive into agentic AI.
Absolutely. We're seeing so much excitement around artificial intelligence generally, but agentic AI, that really signifies a pretty fundamental shift, a shift in how these systems work, and honestly, the kind of impact they're likely to have.
Okay, let's unpack this then. We've really waded through a lot of material, research papers, industry reports, expert analysis to bring you, hopefully, a clear picture of agentic AI. What it actually is, how it works, and why it's generating quite so much buzz right now.
Yeah.
Think of this as your shortcut to getting properly informed.
Yeah, and our mission here, really, for this deep dive is to give you a solid foundation. We want you to walk away understanding the core concepts. So we'll look at what makes agentic AI different, peek under the hood at how it functions, see where it's being used out in the real world, talk about the big advantages it offers, but also, importantly, tackle the significant challenges and ethical questions we really need to grapple with.
Got it. So first things first, let's nail down the definition. What exactly are we talking about when we say agentic AI?
Okay, so put simply, agentic AI refers to systems that are designed to act, well, autonomously, independently, without needing constant step-by-step hand-holding from a human. Imagine, like, digital helpers that can make their own decisions, adapt when things change, set their own sub-goals to achieve a bigger objective, and actually use reasoning to figure out how to get there.
So it's a big leap from just processing info or spitting out content based on a prompt.
A huge leap. The real insight here, I think, is that it moves beyond just automating a task. It's about delegating a goal. It's about goal-oriented delegation, and that can fundamentally reshape how work gets done, potentially leading to, exponential gains.
Right. So it's less like giving super specific instructions and more like saying, okay, here's the ultimate goal. You figure out the best path.
Precisely. It's really a move towards a genuine partnership between humans and machines. We can start delegating more complex, higher-level objectives to the AI.
Interesting.
And what's fascinating is agentic AI usually isn't just one single AI model working alone. Often it involves orchestrating different AI capabilities, pulling in data from various places, maybe even using external software tools to get the job done.
Okay.
And the critical piece enabling all this, it's the huge progress we've seen in these large-scale foundation models, these massive models trained on just incredible amounts of data. They provide the core smarts, the reasoning power that agentic AI systems then build on top of.
Okay, so it's autonomous. That's clear. What are some of the other sort of defining characteristics?
Well, autonomy is definitely number one, as we said. They can perform tasks independently, right? Without needing explicit human say-so at every single step. They initiate actions, they adapt based on what's happening, all without constant checking in.
Right.
Then there's adaptability. This is crucial. These systems are designed to learn. They learn from their environment, from their interactions with us humans. They take feedback, process new information, and adjust their decisions, their actions. This ability to self-improve, to optimize how they work in situations that are always changing, that's really key.
That makes sense. So they're not just rigidly following code. They're learning, evolving as they operate. It's like a constant loop, right?
Yeah.
Try something, see the result, adjust.
Exactly that loop. And they're very goal-oriented. Unlike a system that just executes a command you give it, you hand an agentic AI a task, maybe a high-level goal, and it autonomously figures out the best route to achieve it. Often that means breaking down a big, complex goal into smaller, more manageable steps. And achieving that involves pretty sophisticated reasoning and planning. They can decompose tricky problems, think logically through multiple steps, even reflect on what they did before, search for needed information, and then create quite detailed plans to tackle things.
So it's not just thinking in isolation. It's about taking action, interacting with the world to achieve something concrete.
Absolutely. That ability for interaction with the environment and tools is fundamental. They need to be able to connect with the digital world, maybe even the physical one sometimes. They use tools like APIs, those digital connectors, that let different software talk to each other, or databases.
Right, APIs. Got it.
And they get feedback from these interactions, which then informs their next move. Think of an agent using an API to grab specific data it needs, or maybe executing a piece of code to automate a process.
Okay, that paints a really clear picture of what agentic AI is. Now let's talk about how it stacks up against the AI we might be more familiar with. How does it compare to, say, traditional AI?
Oh, the difference is pretty stark, actually. Traditional AI, it's usually really good at very specific, narrow tasks. It works based on predefined rules or patterns it learned during training.
Hmm.
You have to give it very explicit instructions, very specific prompts. And it can't really make independent decisions beyond its programming. It often struggles when things get complex or require multiple steps, and it tends to be, well, pretty rigid.
Right.
So the core idea here, I guess, is traditional AI automates specific steps in a process. Agentic AI aims for autonomous problem solving to reach a broader objective.
So like an old factory robot doing the same weld over and over that's more traditional AI.
Exactly like that.
Hmm.
Now, agentic AI, it shows a much higher degree of autonomy and adaptability. It can actively plan strategies, change its approach on the fly if new info comes in, make independent choices, and juggle multiple systems or tools to hit its target.
What's
It can even refine its own objectives as it learns more. That's a massive leap in flexibility.
And what about generative AI? Gene AI. That's been grabbing all the headlines for creating text, images, that kind of thing. How does agentic AI relate to that?
Yeah, Gen AI is fantastic, isn't it? Great at creating novel content, text, images, audio, code, whatever, based on the prompts you feed it. Its main job is generating output.
Right. Creation.
Now, agentic AI can definitely use those generative abilities as one of its tools, but it goes way beyond just generating. It autonomously performs tasks, takes actions, makes decisions within an environment. It's about actively solving problems and achieving goals, not just creating stuff.
Ah, I see.
Think of it like this. Gen AI focuses on creating the what. Agentic AI focuses on the doing to achieve an objective. So yeah, the key distinction. Gen AI makes content. Agentic AI takes action.
So Gen AI could, say, write a draft of a report for me.
Mm-hmm.
But agentic AI could potentially do the research, write the report, maybe format it, and then email it off all by itself.
Precisely. That's a great example. And, to really cement these differences, maybe think of it like this. Traditional AI is like a calculator, does specific sums when you tell it to.
Okay.
Generative AI is like an artist, creates something based on your instructions.
Right.
Agentic AI is more like a project manager.
Yeah.
You give it the overall goal, and it figures out all the steps, coordinates the resources, and gets it done.
That's a helpful analogy.
Okay.
Got a good handle on what it is and how it's different. Now, let's dive deeper. How does it actually work? What's the architecture, the engine under the hood?
Right. It's important to realize agentic AI isn't typically one single giant piece of software. It's usually a system, right? A system of interacting parts.
Okay.
And a really key relationship is between large language models, LLMs, and what we call agent frameworks.
LLMs and frameworks. Got it.
The LLMs, they're kind of the brains, providing the ability to understand language, reason, plan. That's crucial. Then the frameworks provide the structure, the scaffolding. They give the blueprints for planning out complex action sequences, for managing memory, what the agent knows and remembers, and for using those external tools we talked about effectively.
So LLM for the smarts, framework for the structure to apply those smarts.
That's a really good way to put it. And absolutely fundamental to how they're designed are these continuous feedback loops, learning mechanisms. That's what allows them to be dynamic, to get better over time.
Okay.
Now, if we break down the core components, the process often looks like a cycle. It starts with perception. This is the agent gathering info from its environment.
Seeing the world around it.
Exactly. Could be data from sensors on a robot, data pulled via APIs, info from databases, maybe even understanding a user interface. Technologies like natural language processing, NLP for text, and computer vision for images help the agent make sense of all this input.
Got it. It needs eyes and ears, digitally speaking.
Next up is reasoning. Here, the agent analyzes the data it just perceived. Often using those LLMs or maybe other specialized reasoning engines, it's looking for patterns, pulling out key insights, figuring out what actions it could take.
Thinking things through.
Right. This involves stuff like breaking down big problems, thinking multiple steps ahead, maybe reflecting on past attempts, searching for more info if needed, and then actually creating a plan. Techniques like ag retrieval augmented generation can come into play here too.
Aye.
Yeah, retrieval augmented generation. It basically helps the LLM reason better by letting it pull in and use up-to-date information from external knowledge sources like a company database or the web.
Ah, okay, so it's not just relying on its initial training data.
Exactly. It makes the reasoning more current and relevant. So after reasoning comes decision-making. Based on all that analysis, the agent evaluates the possible actions and picks the one it thinks is best for reaching its goals. Might use algorithms that weigh the pros and cons of different choices.
Makes the call.
Makes the call.
Hmm.
And then it moves to action execution. This is where rubber meets the road. The agent interacts with its environment, calling those APIs, querying databases, sending commands to software or hardware, maybe executing code, or even talking back to a user.
Okay.
And usually there are important safety checks built in here, guardrails, to try and prevent it from doing something unintended or harmful.
And it's not just a one-shot deal, is it? It learns from what happens next.
Absolutely. That learning and adaptation piece is critical. It's constantly analyzing the results of its actions. Did it work? Did it get closer to the goal? And it uses that feedback to get better next time. Techniques like self-supervised learning or reinforcement learning are often used here to help it refine its strategies.
Constant improvement.
And for really big, complex jobs, you might not have just one agent. You might have collaboration and orchestration involving multi-agent systems.
Multiple agents working together.
Yeah, exactly. You could have several specialized agents, each focusing on a particular subtask, all working in coordination. There are platforms designed just to manage their communication, monitor the overall workflow, handle dependencies between tasks, and optimize how they use resources.
Wow. That sounds like a team of specialized digital workers, all coordinated.
Yeah.
So what are the main technologies making all this possible? You mentioned LLMs and AGI.
Right. So LLMs are definitely foundational language, understanding, reasoning, planning. Then, more broadly, machine learning, ML, provides all the algorithms that let these systems learn from data and improve.
Okay.
Natural language processing, NLP, is key for the human interaction side, understanding and generating language. Reinforcement learning, RL, is super important for teaching agents optimal behaviors through trial and error learning from rewards or penalties from the environment.
Like training a game AI.
Sort of, yeah.
Yeah.
Or training a robot to navigate, or an AI trader to maximize returns. For agents dealing with images or the physical world, computer vision is essential. We mentioned RG for keeping knowledge current. Then there are memory systems. Agents need ways to remember things, right? Short-term memory, often within the LLM's context window, and long-term memory, maybe stored in databases or knowledge graphs, so they retain context and learn over time.
Remember past conversations, maybe.
Exactly, for personalization. And finally, a really defining capability is autonomous tool use. The ability to independently decide it needs a specific tool, like searching the web, using a calculator, querying a database via an API, and then actually use it to achieve its objective.
It's incredible how many different pieces have to work together. So how are these pieces usually arranged? Are there standard ways to design these systems, common architectural patterns?
Yeah, there are several common architectural patterns emerging. One you see is vertical AI. Think of it like a hierarchy. A leader agent coordinates worker agents below it. Good for tasks you can break down sequentially.
Like a manager and their team.
Kind of, yeah. Then there's horizontal AI. This is more collaborative, like a team of equals. Multiple agents work together, share info, tackle a goal jointly. Good when you need diverse expertise working in parallel.
Okay.
You also see hybrid AI mixing elements of both. Another way to think about it is a layered architecture, distinct layers for perception, thinking, and acting. And as we touched on, multi-agent systems, MAS, are a big pattern themselves, with various ways they can coordinate leader worker, supervisor managing specialized agents, or even fully decentralized where tasks get passed around.
So no single right way. Depends on the job. Are there guiding principles then, things developers keep in mind when designing these complex systems?
Definitely. Good design principles are crucial. Modularity is key, building it in distinct blocks so you can update or swap out parts without breaking everything else. Scalability, of course, can it handle more data, more users, more complexity later on.
I got a plan for growth.
Reliability and robustness, making sure it works correctly and consistently, especially when things get unpredictable. Control and predictability are big ones, trying to ensure the agent behaves as intended and doesn't go off in some weird direction.
Yeah, that seems important with autonomy.
Very. And naturally, ethics and bias mitigation need to be considered from the start. Plus, security and privacy, especially with all the data they handle. And finally, user-centric design, making sure it's actually useful and usable for the humans involved.
Makes sense. It's not just about raw intelligence. It's about being dependable, secure, ethical, and usable. What about the actual tools? What platforms are developers using to build this stuff?
The ecosystem is exploding right now. You've got the major AI players, OpenAI, Google AI, Microsoft Azure AI, offering big platforms with lots of tools.
The big cloud providers.
Exactly.
Hmm.
Then you have the fundamental ML frameworks like TensorFlow and PyTorch, the building blocks for the AI models themselves. For scaling things up, especially distributed systems, Ray is really popular.
Okay.
There's also specialized middleware emerging specifically for multi-agent systems, helping agents talk to each other and coordinate. And importantly, a growing number of open source agent frameworks are gaining traction, things like LangChain, AutoGPT, Crew AI.
LangChain, yeah, heard of that one.
Right. They provide pre-built components, ways to chain actions together, manage tools, essentially making it faster for developers to build and experiment with these agentic applications.
So the tools are getting better, more accessible. Okay, this is the really exciting part for me. Where are we actually seeing agentic AI in action? It's moving out of the labs, right?
Right? Oh, absolutely. It's being deployed across a whole range of industries. And it's starting to really change how work gets done, moving beyond just automating the easy, repetitive stuff.
Right.
As these systems take on more complex tasks autonomously, you see the human role shifting, often towards more strategic oversight, managing the goals, handling the exceptions. One thing to remember, though, is that success in the real world often hinges on really good data integration. Garbage in, garbage out still applies, maybe even more so.
Makes sense. Okay, let's talk sectors. Healthcare always comes up as a huge potential area for AI. What's happening there with agentic AI?
Yeah, healthcare has massive potential. We're seeing early applications or strong potential in things like personalized patient interactions. Imagine an AI agent proactively checking in, providing tailored advice based on your history, and maybe even real-time data from wearables.
Wow.
AI-assisted diagnostics is another big one, helping doctors analyze medical images like X-rays or MRIs faster and potentially more accurately, spotting things earlier.
Okay.
Then there's streamlining operations, automating appointment scheduling, managing records, processing insurance claims, maybe even optimizing staff schedules or patient flow in a hospital.
The admin burden.
Exactly. It's even being used experimentally in drug discovery, analyzing massive biological data sets, generating hypotheses about potential drug candidates. Systems like ChemCrow are exploring this, plus predictive maintenance for expensive medical gear, virtual health assistants offering 24/7 support, and even AI assistants in robotic surgery for enhanced precision.
Incredible range.
It really is. The core insight in healthcare, I think, isn't just efficiency. It's this potential shift towards more personalized, proactive, and maybe even preventative care.
That's huge. Okay, what about finance? They're usually quick to adopt new tech.
Definitely. In finance, agentic AI is making waves in fraud detection, analyzing transactions in real time, spotting anomalies that might indicate fraud. MasterCard is doing work here.
Right, security.
Automated trading is another area. Agents processing vast market data, making split-second decisions to execute trades optimally. Firms like QuantEdge are pioneers. Then there's personalized financial advice. Robo-advisors using AI, like Wealth AI, creating tailored investment plans.
Making advice more accessible.
Potentially, yeah. And behind the scenes, it's streamlining core processes, automating account reconciliation, expense reporting, compliance checks, improving cash flow forecasting, and liquidity risk management. So in finance, it's really about enhancing security, speeding up decision-making, and offering more tailored services.
Safeguarding money, and making the system run smoother. Got it. Let's switch to something more physical manufacturing. How's it being used there?
In manufacturing, agentic AI is a key driver of the whole smart factory concept, optimizing production lines in real time, adjusting based on demand shifts, material availability, equipment status. Siemens has their industrial co-pilot helping engineers with this.
Adapting on the fly.
Exactly. Predictive maintenance is huge here too. Using AI to monitor machinery, predict failures before they happen, minimizing downtime. Companies like Siemens, Toyota, Boeing are all investing heavily in this.
Saves a lot of money, I bet.
Huge savings. It's also used for optimizing complex supply chains, improving quality control AI vision systems, spotting defects much faster and more accurately than humans can, and managing resources like materials and energy more efficiently. The key theme in manufacturing is really driving efficiency, uptime, and quality.
Okay, from factories to our direct interactions. What about customer experience? How is agentic AI changing that?
It's enabling much deeper personalization, hyper-personalization, analyzing customer data to tailor interactions, recommendations, support in ways we haven't seen before.
Beyond just using my first name in an email.
Way beyond. Think smart assistants and chatbots that can handle really complex issues autonomously, not just FAQs, but resolving billing disputes, walking you through complicated technical support.
That'd be nice.
Wouldn't it? It can also be proactive. Identifying potential problems, maybe a flight delay, and resolving them, like rebooking you automatically, maybe even before you know there's an issue.
Wow.
In e-commerce, it's driving dynamic merchandising, optimizing the online store experience for each visitor in real time, and intelligent self-service knowledge bases that learn from customer interactions to keep getting better. So the trend in customer experience is towards more proactive, deeply personalized, and seamless support.
Making things smoother and more relevant for us. Are there other big areas jumping out?
Oh yeah, plenty. In education, personalized learning is a big theme. AI tutors like Conmigo or Georgia Tech's Jill Watson adapting to individual student needs.
Tailored learning.
Exactly. In scientific discovery, it's automating laborious parts of research, sifting through papers, generating hypotheses, even helping design experiments in fields like chemistry or biology. Tools like ChemCrow or ProteAgents are
Or
examples.
accelerating science.
Hopefully. Smart cities are using it for optimizing traffic flow, managing energy grids, coordinating emergency responses. Look at Pittsburgh's Surtrack system or Singapore's Smart Nation initiative.
Urban efficiency.
Then there's robotics and autonomous systems, self-driving cars like Waymo, smarter drones doing complex inspections. Content creation is getting more automated and personalized. IT operations and cybersecurity are using it for automated incident response. Threat hunting exabeam is a player here. Even human resources, streamlining recruitment, onboarding, employee support, PepsiCo's explored this. It's really touching almost every sector.
The breadth is just astounding. Feels like we're just scratching the surface. So pulling this together, what are the main overarching benefits that agentic AI offers? Why are businesses so excited?
Well, the advantages are pretty compelling. First and foremost, it's about supercharging productivity and operational efficiency. Automating not just simple tasks, but complex workflows frees up humans for higher value, more strategic work. It minimizes human error, and these agents can work 24/7.
More output, less routine work for people.
Right. Second, it enables smarter, faster, data-driven decision-making. These agents can crunch vastly more data than humans, spot subtle patterns, provide insights that lead to better choices. They allow for continuous strategy refinement based on real-time feedback, better forecasting, better problem-solving.
Making better calls based on actual data. Makes sense. What else?
It unlocks huge scalability and adaptability. Businesses can scale up operations without necessarily needing a proportional increase in headcount. And crucially, they can adapt quickly to changing market conditions or new data, interpreting context, and adjusting workflows on the fly.
More agile.
Exactly. It also has the potential to enhance human capabilities and foster collaboration. It's not just about replacing tasks, but augmenting our skills, maybe leading to entirely new kinds of jobs focused on managing and collaborating with AI. You could even see AI agents collaborating with each other on very complex problems.
Augmenting, not just automating.
That's the hope for many roles. And finally, all this can lead to significant cost reduction and revenue growth. Lower operational costs from automation, better customer experiences driving loyalty, efficient scaling, capturing new market opportunities, AI-driven recommendations boosting sales. It impacts the bottom line. Remember that Accenture projection. Over $150 billion in annual savings just in U.S. healthcare by 2026.
Those are some powerful potential upsides. But,
Yeah.
and there's always a but with powerful tech. What are the catches, the challenges, the risks we need to be thinking about?
Absolutely. The potential is huge, but so are the challenges. We're dealing with a really complex mix of technical, ethical, and security concerns here. And honestly, in some ways, the tech might be advancing faster than our ability to fully understand and mitigate all the risks. Relying on humans to constantly oversee every autonomous action just won't scale.
Okay.
On the technical side, just the complexity of these systems is a huge hurdle. They need massive computing power, sophisticated algorithms, deep contextual understanding, making them difficult and expensive to build, deploy, manage, and maintain.
Not easy stuff.
Not at all. Then there's reliability and robustness. Can we guarantee they'll operate correctly and consistently, especially in messy, unpredictable real-world situations? Small errors could potentially cascade into big problems.
Right, if they're making decisions autonomously.
You need to trust those decisions. which leads to control and predictability. It can be really hard to anticipate exactly how an autonomous agent will behave, especially in novel situations, or when you have multiple agents interacting, you can get unexpected emergent behaviors. How do you ensure they pursue goals in ways we actually want?
The rogue AI fear, even if unintentional.
Well, maybe not rogue in the sci-fi sense, but certainly pursuing goals in undesirable ways. Scalability itself is a challenge, especially for companies trying to build their own systems. It's resource intensive. We hear about high failure rates for DIY AI projects trying to scale,
Mhm.
and data challenges are ever present. Agentic AI is hugely dependent on data quality. Data silos, poor quality data, biases baked into the data. The old garbage in, garbage out principle is magnified here.
Right.
Finally, just integration with existing IT systems, legacy databases, different APIs can be a massive, complex, expensive headache. So yeah, the power is gated by the complexity, the need for better reliability, predictability, and manageability.
Beyond the purely technical, what other big rocks are in the road?
One major cluster is around securing autonomy. This involves several things. Data privacy risks are significant. These agents often need access to vast amounts of potentially sensitive data. How do we prevent unauthorized access, breaches, ensure compliance with regulations like GDPR or CCPA?
Big responsibility.
Huge. Then cybersecurity vulnerabilities. These complex AI systems create new attack surfaces. Think adversarial attacks designed to fool the AI, exploiting software bugs in the AI systems themselves, things like prompt injection or even poisoning the data they learn from. Traditional data breaches are still a risk too, of course. AI-targeted attacks are seen as a top risk now.
So new ways for bad actors to cause trouble.
Potentially, yes. And we also have to consider the potential for unintended consequences and misuse. Even without malicious intent, an autonomous agent might take actions that turn out to be harmful or maybe even illegal. There's research showing potential for emergent deceptive behaviors in advanced models, things researchers call alignment faking. And of course, the risk of these powerful tools being deliberately used for malicious purposes is a serious concern.
Yeah, that's sobering. The autonomy really amplifies both the good and the potential bad.
It does. And that really underscores the need for robust ethical frameworks and proactive governance before this technology becomes ubiquitous. We can't just build it and figure out the ethics later.
Absolutely. So let's pivot to the future then. Looking ahead, say the next 5 years, 2025 to 2030, maybe beyond, what's the trajectory? Where is agentic AI heading?
The arrow is definitely pointing up, and steeply. We're looking at increasing integration into, well, almost everything. Market projections are showing really significant growth.
Big numbers.
Yeah, some analysts see the market growing from maybe $7 billion in 2025 to over $40 billion, maybe close to $50 billion by 2030. That's a huge compound annual growth rate, over 40%. Enterprise adoption is expected to jump dramatically, too. Gartner predicts maybe a third of enterprises using agentic systems by 2028, up from less than 1% now. Some surveys suggest over half of companies might have deployed them by early next year.
Wow, that's fast adoption.
It is. Mark Benioff at Salesforce even predicted a billion AI agents by the end of 2026. And the investment is pouring in billions in private funding for Gen AI generally, which fuels agentic AI, specific funding for agent startups, big tech pouring money into research. The potential economic impact estimates are massive, $2 trillion added to global GDP annually within the decade.
Okay, so rapid growth, big investment. What about the capabilities? How will the agents themselves evolve?
We'll see continuous improvement. They'll get much better at self-improvement learning faster, correcting their own mistakes, refining strategies without human intervention. Multi-agent collaboration will likely become more sophisticated agents negotiating better, coordinating resources more dynamically.
Smarter teamwork.
Exactly. We might see more emergent behaviors potentially leading to novel solutions, but also needing careful monitoring. Reasoning abilities should deepen, maybe even developing a kind of metacognitive awareness, understanding their own limitations. We'll likely see more flexible underlying models, maybe liquid foundation models or other hybrid approaches. And they'll become much better at personal adaptation, tailoring themselves more precisely to individual users' needs and preferences.
Sounds like they're becoming more intelligent, more capable partners. What does this mean for businesses? You mentioned the agentic enterprise.
Yeah, that's the vision many people are talking about, the agentic enterprise. We could see AI agents becoming a core part of the digital workforce, like virtual employees handling a wide spectrum of tasks. Some even suggest IT departments might evolve into something like HR for AI agents.
Interesting thought.
We'll likely see more autonomous operations, logistics networks that optimize themselves. Smart factories running with minimal human oversight for routine stuff. Maybe even AI-led teams in healthcare handling standard procedures. Automation of work decisions is projected to increase significantly. Companies are already anticipating automating a large chunk, maybe 25–50% of their current workload.
That's a major shift.
It is, and the message from many analysts and tech leaders is clear. Proactive adoption is becoming a strategic necessity. Businesses that don't start figuring this out risk falling significantly behind. The core idea is AI agents becoming integral workers, driving much more autonomous business operations.
A truly transformative outlook. Now, who's actually building this future? Who are the key players, the companies, the researchers leading the charge?
It's a really diverse ecosystem, which is exciting. You've got the major cloud providers and AI labs we mentioned earlier, Microsoft, Google, AWS, IBM, NVIDIA, OpenAI, Anthropic, all investing heavily in building foundational platforms.
The usual suspects, the tech giants.
Right. Then you have established enterprise software and automation players, Salesforce with Agentforce, ServiceNow, UiPath, automation, Anywhere, and others who are weaving agentic capabilities into their existing offerings. They're building that agentic layer on top.
Integrating it into business tools.
Exactly. And then there's this explosion of specialized and emerging companies, just a huge number of startups focusing on specific niches or building new kinds of agent platforms. Names like Cognosis, Crew AI, Relevance AI, LivePerson, Workday, Adept AI, Cognition Labs with their Devon coding agent, Hippocratic AI in healthcare. The list goes on and on.
A real Cambrian explosion of agent startups.
That's a good way to put it. And don't forget the academic side. Leading research universities are crucial. MIT CSL is doing foundational work on interpretability, multi-agent systems, even conflict resolution for autonomous cars. Stanford's HAI focuses on human-centered AI and publishes that influential AI index report.
Right, Stanford HAI.
Carnegie Mellon has research centers focused on human-AI interaction, teamwork, even using agents for career exploration. UC Berkeley's BR lab is pushing boundaries in areas like agent memory and transparency. These academic labs are really driving fundamental breakthroughs.
So it's industry and academia working in parallel, sometimes together.
Definitely. And you also have influential voices, researchers publishing key papers, organizations like the World Economic Forum analyzing impact, industry analysts tracking trends, authors writing books trying to make sense of it all, and tech leaders like Bill Gates or Jensen Huang proclaiming agents as the next big platform shift.
It's clear this isn't just a niche tech thing. It's becoming a major focus across the board.
Yeah.
Okay, as we start to wrap up this deep dive, let's distill it down. What are the absolute key takeaways you want our listeners to leave with?
We've definitely covered a lot. But the core message, I think, is that agentic AI is a really significant evolution. It's moving AI from tools that process or create for us to autonomous partners that can reason, decide, and act alongside us to achieve complex goals.
From tool to teammate, almost.
In a way, yeah, its potential to boost productivity, sharpen decision-making, and spark innovation across nearly every field is just immense. And it's big, but we absolutely have to navigate the technical hurdles, the security risks, and especially the ethical challenges very carefully and proactively.
Right. Responsible development is key.
Crucial. And as these agents become more capable and integrated into our work and lives, our own roles, human roles, will continue to evolve. It's less about replacement across the board and more about collaboration, oversight, and focusing on uniquely human skills like creativity, complex problem solving, and empathy.
So embracing the potential while managing the risks and adapting ourselves along the way.
Exactly. The future with agentic AI holds incredible promise. But realizing that promise in a way that benefits everyone requires wisdom, foresight, continuous learning, and open dialogue.
Well said. So as you, our listener, think about what this means for your industry, your job, or just your interests, remember, this field is moving incredibly fast. Keep exploring, stay curious, question things, and think critically about how we can best harness this powerful technology for good. Thanks for joining us on this deep dive into agentic AI.